Combustion is an exothermic reaction in which a compound is added with oxygen and with the help of activated energy produces water and carbon dioxide. In this example of a combustion reaction, methane is being reacted with oxygen, which combusts to produce carbon dioxide and water.
Exothermic reactions, a reaction in which heat is a product. In an exothermic reaction, the products have less enthalpy than the reactants, and using the equation shown, enthalpy is negative, equaling an exothermic reaction. In this example, glucose and oxygen react, yielding water, carbon dioxide, and energy. Energy is a product. Therefore, this reaction is exothermic.
Enthalpy equals delta H. In an exothermic reaction, delta H is negative, indicating a release of heat. In a potential energy diagram for an exothermic reaction, as shown here, the reactant's potential energy is higher than that of the products. This energy difference is what makes up the enthalpy. If the reaction was endothermic, the products would be higher than the reactants.
Calcium carbide is our reactant. A pipette is used to deliver distilled water onto the calcium carbide. An ignition wire provides activation energy. The acetylene cannon apparatus is where the reaction takes place. We are using plush molds as our ammo.
Here are some safety precautions to take before conducting this demo. Wear earplugs if sensitive to noise. Keep the cannon vertical when there is calcium carbide in the cap. Warn those around you before firing. And don't shoot anything heavier than a plush mold. And most importantly, don't forget to wear goggles.
First, set up a scale and make sure that the units are in grams. Place a weigh boat onto the scale and zero the scale. Second, with a scoopula, measure out roughly 1 gram of calcium carbide. Next, pour the measured calcium carbide into the cap of the acetylene cannon apparatus. Screw the cap back onto the apparatus, making sure to keep the cannon vertical when doing so.
With a pipette filled with 1 to 3 milliliters of distilled water, add the water into the ignition hole. You should be able to hear the reaction fizzing when you listen closely. About 20 seconds after adding the water, put the ignition wire into the acetylene cannon, aim, and click the button to fire the mole. Here are the equations for the reaction of calcium carbide and the combustion of acetylene. The reason why there are 2 equations is because the first equation is the creation of acetylene. Then, this acetylene is used in the combustion equation, for which this is what causes the loud bang. The calcium carbide in the cap reacted with water creates acetylene gas and calcium hydroxide. After about 20 seconds, acetylene is produced, then oxygen in the air and the acetylene mixture is ignited, creating an explosion in which the mole was propelled out of the cannon.
Since the acetylene gas reaction is a combustion reaction, the reaction is exothermic. Like stated earlier, this makes the change in enthalpy negative.
Here's an image of the excess from the reaction, specifically excess calcium carbide, calcium hydroxide, and water.